China's Lifeline $80 billion megaproject. South-North Water Transfer Project. China's South-North Water Transfer Project, SNWTP, is one of the most ambitious engineering feats in human history. With the goal of diverting nearly 45 billion cubic meters of water annually from the water-rich south to the arid north, it's a national-scale solution to a looming water crisis. While the project brings undeniable benefits, it also highlights the complex choices involved in managing natural resources across a vast nation. In this short story, we explore the journey of this megaproject, from design to implementation, engineering breakthroughs, and its enduring impact. The vision: a nation divided by water. China's geography presents a stark imbalance. The south, especially the Yangtze River Basin, enjoys abundant rainfall and river systems, while the north, home to megacities like Beijing and Tianjin, and the industrial heartland of Hebei and Hunan, suffers from chronic water scarcity. By the early 2000s, over 40% of China's population lived in the north, but had access to only 6% of the nation's freshwater. Northern rivers like the Yellow River were shrinking, groundwater levels were dropping, and droughts were threatening food security and urban development. The country needed a long-term solution. The grand design: 3 routes, 1 goal. The SNWTP was China's answer, a visionary plan to connect the Yangtze River with the Yellow, Huai, and Hai River basins in the north. Eastern Route: modern engineering meets ancient waterway. The eastern route of the SNWTP, operational since 2013, revives and modernizes the ancient Grand Canal to carry water from the Yangtze River toward the northeastern provinces of Shandong and Tianjin. Covering a length of over 1,100 kilometers, this route uses 51 state-of-the-art pumping stations to move water across flat terrains and slight elevation gains. As the land in this region is mostly flat, gravity could not be relied upon entirely, making mechanical pumping essential. To address the challenge of maintaining water quality along a route that passes through industrial regions, China installed numerous water treatment plants to monitor and clean the flow. Pollution control has been a key focus, with strict oversight to prevent contamination. Additionally, concrete-lined canals and some covered segments help reduce water loss due to evaporation and seepage. This route supports urban water supply and agricultural irrigation in provinces like Jiangsu and Shandong, reducing stress on local groundwater reserves and contributing to stable food production and regional development. Central Route: a gravity-fed lifeline to Beijing. The Central Route, operational since 2014, is the most iconic and vital component of the SNWTP. It carries water from the Danjiangkou Reservoir in Hubei province directly to Beijing, Tianjin, and major urban centers in Hunan and Hebei provinces. This route stretches over 1,400 kilometers and uses natural elevation differences to move water without requiring pumping. The elevation at Danjiangkou is 147 meters higher than Beijing, allowing for a gravity-fed system that is energy efficient and highly reliable. Engineering marvels on this route include long tunnels carved through the Qinling and Funyo mountain ranges. The use of tunnel boring machines, TBMs, allowed for precise and deep excavations, with some tunnels stretching up to 85 kilometers. Reinforcement technologies, including blasting and concrete lining, ensured stability through complex geological layers. The Yellow River crossing is a particularly notable achievement, involving a 7-kilometer siphon system that carries water underneath the river in sealed, pressurized pipes to prevent contamination. This route supplies over 70% of Beijing's drinking water and has drastically improved the water situation in northern China. It also plays a vital role in recharging groundwater, restoring lakes like Baiyangdian, and supporting the expansion of industries and urban infrastructure. Western Route: the frontier of possibility. Still in the planning phase, the Western Route represents the most technically ambitious leg of the SNWTP. Its goal is to divert water from the upper tributaries of the Yangtze River on the Tibetan Plateau to feed the Yellow River, thereby supporting arid regions in Gansu, Ningxia, and Inner Mongolia. This route is expected to cross some of the most challenging terrain in China, including the Bayanhar and Kunlun mountain ranges, where elevations exceed 4,000 meters. Engineering challenges include tunneling through high-altitude, earthquake-prone zones, and managing extreme cold temperatures. Plans involve constructing extensive deep tunnels and possibly installing heating and insulation systems to prevent freezing. Additionally, the route must address sediment-heavy flows and high evaporation rates due to altitude and temperature swings. While still under review, this route has the potential to unlock water security for Western provinces and ensure balanced national development. Given its scale and complexity, this leg of the project requires thorough environmental assessments and careful geopolitical considerations, as some rivers in this region flow into neighboring countries. China is proceeding cautiously with scientific studies and diplomatic dialogue to ensure the route's feasibility and international cooperation. Water for the North, transforming cities and farms. The SNWTP has changed the fate of northern China. Before this project, water scarcity was a defining limitation for cities, industries, and rural agriculture. Now, over 40 million people have access to a reliable water supply. The transformation is visible in how cities plan for growth, how industries run operations, and how farmers plant and harvest with confidence. The agricultural sector has seen perhaps the most noticeable shift. In provinces like Hunan and Hebei, once plagued by droughts and groundwater depletion, farmlands are now well irrigated. Crops such as wheat and corn benefit from regular water access, leading to increased yields and better income for farmers. This steady water supply has helped stabilize food production and has made northern China more food secure. Specific success stories reinforce this impact. For example, Anyang City in Hunan, once suffering annual crop failures due to dry seasons, reported a 40% increase in wheat harvests since the SNWTP became operational. Shijiazhuang, the capital of Hebei, saw a revival in apple and vegetable farming thanks to timely irrigation made possible by transferred water. These local triumphs ripple outward, strengthening national grain reserves and lowering reliance on imports. Industry, too, has boomed with the availability of water. Water-intensive industries like textiles, chemicals, and electronics now have consistent access to resources necessary for expansion. Factories in cities such as Shijiazhuang, Zhengzhou, and even Beijing have ramped up production. The ripple effect is significant: more jobs, more exports, and an enhanced industrial base contributing to China's overall economic power. Economic resilience has grown stronger, especially during dry years. In 2019, when drought hit several northern provinces, water from the SNWTP prevented factory shutdowns in cities like Handan and Baoding. Water continuity ensured that industrial output remained steady, and power plants relying on hydro-cooled systems avoided blackouts. Urban development has gained momentum. Cities that once faced limits on population growth due to water constraints are now welcoming millions. Beijing alone now receives over 70% of its drinking water through the SNWTP. With reliable water infrastructure, urban planners have undertaken massive housing, transit, and infrastructure projects, improving quality of life for residents. Transportation has indirectly benefited as well. As cities and industries expand with new infrastructure, water routes and road logistics have evolved. Some canals are now used for transporting goods, and the rise of newly planned industrial zones near these water networks has made cargo movement more efficient. Water is no longer a barrier but a bridge that connects regions economically and socially. In every sense, the SNWTP has rewritten China's future. From feeding cities and farms to energizing factories and enabling urbanization, this single project has left an unmatched legacy on the nation's geography and economy. A global legacy of Chinese engineering. Beyond its domestic achievements, the South-North Water Transfer Project has elevated China's status as a global engineering leader. Following the successful completion of the eastern and central routes, Chinese engineers and hydrologists gained invaluable expertise in tunnel boring, siphon systems, and gravity-fed canal designs. This knowledge has been exported through the Belt and Road Initiative, with Chinese-led water infrastructure projects now underway in countries like Pakistan, Egypt, Laos, and Ethiopia. What started as a solution to a national crisis has become a model for transboundary water cooperation and resource distribution. Today, China's SNWTP is studied by engineers, economists, and policymakers around the world. As climate change intensifies and freshwater becomes increasingly scarce, the SNWTP stands as both a bold answer and a powerful lesson in the possibilities and responsibilities of large-scale water engineering.